Hello, this is a video for the 3.1 graphing linear inequalities in two variables. Just to make sure you guys got the concepts down, I know I had to sub for this material, so I always like to do it in my own words just in case you like my style and you wanted to see it that way. So this is procedure for graphing a system of linear inequalities is that we're going to graph each linear inequality using arrows to identify the solution sets. Shade the region that all of the solution sets have in common. So when you graph a linear inequality, especially if you haven't done one in a while, you graph it as a line, so y equals mx plus b, and then you have to determine whether or not the line is solid or dashed, because that is if it has an equal to or not. And then you have to determine which side would be shaded, because an inequality, if it's greater than or less than, you would need to know, okay, if it's greater than, I shade above where the graph crosses the y-axis. And if it's below or less than, we would shade below. So procedures for graphing that is you need to know dashed or solid, graph the associated equation, that's the y equals mx plus b, and you can determine this the solution set by just testing an ordered pair and seeing if it comes out true or false. So the solution set of a system of linear inequalities, so if you graph more than one, it will be called bounded if it's enclosed by a circle, if you can. So in other words, the graph doesn't go off forever. Otherwise, it is unbounded. So we're going to be determining graphically the solution set for each system of inequalities and indicate whether the solution is bounded or not. So for this first one, let's try to, and I think this one's later on, yeah. We will be graphing that one in just a second, so we're going to get to that. We're going to look at this first set of examples here, and we're going to talk through what the equations would have looked like if they had been inequalities, because right now they're listed as equations. So it says write the system of linear inequalities that describes the shaded region. So look at this first horizontal line, that's y equals 4. We shaded below that line, so that means that y would have been less than, and this is a solid line, or equal to 4. That would have been the inequality that matches with that since it's shading below. This is y equals x. And notice this is hard because a lot of people don't know if this is above or below. If you go down to where that line crosses the y-axis, if the shading is up, then you're dealing with a greater than problem. If the shading is down, you're dealing with a less than problem. So we're actually shading greater than or equal to the x. So y is greater than or equal to x since they shaded above. And then this one is x plus y equals 3. Again, find where that is on the y-axis, where that point crosses, and notice that it is shading above that. So this will be x plus y is greater than or equal to 3. Now, sometimes you do want to solve that one for y to make sure, because sometimes when you solve it, you might end up having to flip a sign if that was like a negative y. So it is important to be careful about that. So let's look at another one. And this is a bounded system because, look, we can enclose that whole shaded region with a circle. So if you look at this one, there's some things going on here you don't see. I'm going to draw them in. This is also bounding this graph, but see, because it doesn't go below those lines. This is the line, we're going to call that one, this one's the x equals 0. It's a vertical line at x crosses 0. And this is a horizontal line at y equals 0. So we are shading to the right of this vertical line. That means that x is greater than or equal to 0. We are shading above y equals 0. So that's also greater than. This is the line x plus y equals 2. And again, the y is positive here, so there shouldn't be any weird flipping of signs. And if you look at the positive 2, we are shading on the top side of that line. So that would be x plus y is greater than or equal to 2. For 9x plus 5y equals 90, here we cross at 18. And notice that the shading is below, so that will be 9x plus 5y is less than or equal to 90. And same thing for 3x plus 5y equals 60. Here's where that crosses the y-axis, and we are shading below. And like I said, the only time you'll have to be careful there is if the y is negative in this equation. Then you would have to think, okay, if I solved this, I would have to flip by dividing by a negative. So then we'd want to switch our thought on how to write the sign. So then this one is x equals, and this one is also bounded, by the way. X equals 2, we're shading to the right of it, so that would be X is greater than or equal to 2. Y equals 7, we're shading below, so that would be less than or equal to 7. Y equals 3, we're shading above that, so Y is greater than or equal to 3. And this X plus Y equals 7, here's the Y intercept, we are shading on the top side of that. So that is going to be greater than or equal to as well. All right, so this one is unbounded because notice this goes on forever even though they don't keep drawing it. For X plus Y equals 16, we are shading on the top side of that. So that's greater than or equal to. This is the line 5x plus 4y equals 40. And here's the y-intercept. We are shading on the top side of that. So that'll also be greater than or equal to 40. And this is the line x plus 5y equals 20. We're also shading above. So that's why this one's unbounded. It goes above in all directions without ever being stopped. Okay, so we're going to go through and graph some of these. So we're going to determine graphically the solution set for each system of inequalities and indicate whether the solution is bounded or unbounded. So one way to graph these is to use x and y intercepts. That's sometimes easier. So I'm going to think of x plus y equals 6. If these both divide equally into that number, that makes it really easy just to graph the intercepts. So if you plug in 0 for y, you get x equals 6. If you plug in 0 for x, you get y equals 6. So that's the ordered pair 6, 0, and 0, 6. So here and here. And that line is solid. So let's see if I can just insert a line. That would be easier than trying to draw it by hand. And I'll have to adjust this a little bit. There we go. And there we go. So that's my first line. Let's see if we can make that darker. Make it black and maybe a little bit bolder. Okay, so you can see that. And then we have this 0 is less than or equal to x is less than or equal to 3. You can split that into two separate inequalities. It's a compound inequality. This actually says x is greater than or equal to 0 and x is less than or equal to 3. So greater than or equal to 0 would be this. That's just x equals 0. So that's going to be this vertical line here. Yeah, I should just not draw. Let's use a line again. So I'm going to grab another line. If it'll let me. Hang on just a second. There we go. So there is x is, and for some reason it's not wanting to cooperate. There we go. X is equal to 0. And then we're also going to have x is equal to 3 because that is a vertical line on the other side. And I'm just going to try to copy this and move it to where I need it. And then y is greater than 0. So we need one more line, but it's going to end up being horizontal. Okay, so there's all the lines that are on this graph. Okay, so then we have to do what's the shading. Now the easiest way to do this is to indicate for each line where should we shade. And I like to sometimes do that in like a different color. So x plus y is less than or equal to 6. If you want to, sometimes it's easier for people to tell where they're shading if they solve it for y. This says y needs to be less than that line. So if you go to the 6 where that line crossed, we need to be shading below. Okay, and then x is between 0 and 3. That means we're going to be shading towards the right. For the x is greater than 0. And we're going to be shading to the left for the x is less than or equal to 3. And then y is greater than or equal to 0 means we take this horizontal line and we shade up. Now the place where the answer is where all of the arrows are going to be in the same area. So it's actually this region right here, this little trapezoid that this made. That's the only area where all of the arrows appear for each part. So it's just bounded into this. And it is bounded because it does not go off forever in any direction. Okay, let's look at another one. So this is 3x minus 6y is less than or equal to 12. Let's do that line. Let's do all three of these in different colors. So let's do that one in blue. We're going to work the whole thing out. So this is 3x minus 6y is less than or equal to 12. I like to do intercepts, so if I let each part equal 0, I get these two situations. So x is 4 or 4 comma 0. And y is negative 2 or 0 comma negative 2. So we're going to have to draw where we think that is, which I'm going to guess is right down here. And 4, 0 is here. We're going to draw a line for that. We'll have to adjust it. Sometimes it doesn't like that I have a graphic here. And we'll move this one down just a little bit. If it'll let me. Well, we're close enough. So this is blue. We're going to go ahead and leave it blue, and we'll make the weight of it a little bit larger. Okay, so that's this line. And it does bother me that that's off a little bit. There we go, and that one needs to be up a little bit. Okay, so then this needs to be, if you solve this for y, this would be subtract the 3x over, so negative 6y is less than or equal to negative 3x plus 12. Divide everything by negative 6. That will flip the inequality. That's why it's so important to do that, and that would be 1/2 x minus 2. So notice that this right here, we're actually going to be shading above because there was a negative y. That's why I pointed that out a couple of times. If it's a negative in between the y's, it is very possible that the inequality is going to flip. So we're actually going to be shading above, and I'm going to use my highlighter here. So I'm shading above, 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 above. Okay, let's do the next line. So let's do it in a different color. Let's do red. So negative x plus 2y is less than or equal to 4. If I do my x and y intercepts, this will be x is negative 4 or negative 4 comma 0. This will be 2, so 0, 2. I'll need to extend this line out a little bit, so I can do negative 2, negative 3, negative 4. I know those are not perfectly spaced. So negative 4, 0 is over here, and 0, 2 is right here. So let's insert that line. Best we can, and we'll do, let's do red for the line. It's not wanting to let me. Just 1 second. Well, I'm just going to darken it in. It's not going to let me change it again. Okay, so then this one, we need to figure out which way we're shading. Again, I would probably solve this for y by adding the x over, dividing by 2. This is also one way you could graph them. And these lines are supposed to be parallel, but my line drawing ability is not that great. Let's see if we can fix that. I don't know that it's going to let me adjust that line. We can try. There we go. Yeah, because I didn't nicely space out my X's and Y's, these are actually supposed to be parallel lines, but it didn't quite look that way because of the way I graphed it. So as parallel as I can get them to look. So I'm going to make this line kind of orange. Okay, now for the important part, where are we shading? So we're shading below. See how this is Y is less than or equal to. So I'm going to shade with the pink, and we're shading down. Okay, and then we have X is greater than or equal to 0, which means we have the line X is greater than or equal to 0 is this vertical line here, and we're going to be shading to the right, so we'll use yellow for that. Just trying to show you with colors kind of how this is supposed to graph out. It does make this messier, but it hopefully will help you see where the overlap is. And then we're going to do Y is greater than or equal to 0, so that's the line down here. And then we're going to shade above that. So you can kind of see here in the middle, from here down to here, over to here, following this line up, following this line across. All of that has all of the colors overlapping. So then if we go back and now we kind of erase out those highlighter marks, you'll be able to see. So I'm just erasing any of them that are kind of showing you too much and getting kind of in the way of visualizing what's going on here. So once we saw where the overlap was, we were able to tell where to shade. So if you need colored pencils on a test or something like that, that's perfectly fine. So let me actually shade this in using maybe the pink. So all of this is our shaded region. And this one is unbounded because notice this goes out forever without any stopping point. All right. So there are 3 more of these on this video or on this section. What I think I'm going to do is I will work them out and post them for you because I know this video is very long already, so that you guys can try them on your own and then see how that you are doing with them. All right. I will see you guys in class next time.